Hi everyone. My name is Krishnan. I come from a small startup in the Bay Area called Juxt.io. We're doing some interesting stuff with making business analytics more consumable by business users, non-technical users. And this talk's going to be primarily about some of the experiences that I've had building the system that we are working on and using Clojure to solve some of these issues. I've been a programmer for over 20 years. I started my career using C and Lisp, Smalltalk, Erlang, Java, and then I discovered Clojure around 2009. I've actually built a few applications, commercial applications, one in streaming media, one in ed tech, and worked on some interesting problems in e-commerce. Okay. This is my first conj, by the way, and so I'm really excited. Oh, thank you. So if I mix up my lines or something, please forgive me. It's just the excitement. Okay, so this is a story from India. It's about, some of you may know this, but I'll just quickly run through it. It's about this king who asks these blind men to go examine this new animal that's walked into the kingdom and report back on what it is. I don't know why he picked blind men, but he did. They picked different parts of the animal and drew completely different conclusions. The guy who was, who touched the tail thought it was a snake. The guy who was feeling up the legs thought it was a pillar, and so they came back with perfectly reasonable conclusions, but they were just wrong. And obviously the insight that went up to the king was patently false. Business analytics sometimes feels this way. Let me see if I can, oh, I get it. Hello? I apologize. Why does it not want to switch? Huh? You think you're prepared for everything. Oh, whatever that was. Ah, goodness. Do you guys mind if I just left it in this state? Okay, thank you. So business analytics feels a lot like this. We've gotten very good at collecting data and storing it in lots of different shapes and myriad technologies. We've carved up the functions across all these boundaries, and each of these functional groups have come up with their own tool sets and tooling. And they do great at what they do, in terms of piecemeal analytics, but they don't do a good job integrating all of it and forming a cohesive picture going up to, in this particular case, a line of business leader. And so this integration isn't just about plugging results from each of these groups into another spreadsheet and coming up with another chart that the line of business leader can look at. Insight really comes from collaboration across all these boundaries. So if a line of business analyst comes up with a question which is implemented using artifacts that are created by the data analyst or data science teams, then conversely, new products that come out of data science and data analysts need to be able to come back and influence the direction of the questions or what kinds of questions are being asked. So there needs to be a much more open, much more visible way for all these teams to share, collaborate, and enrich the overall tooling. Just a quick word on the reality of data tools. So we seem to be stuck in this schism of, it's either user-friendly or it's powerful. So, business analysts will use Excel because it's user-friendly. Excel is a great tool. I'm not knocking any tools here. I'm just saying that we've kind of carved ourselves into these niches where these teams have, these tools don't necessarily talk to each other well. Throwing a CSV over the wall isn't integration, right? Or a JSON file isn't integration. You need something a little bit more bidirectional, something that propagates in either direction. That's the core premise here, that integration and collaboration is what makes insight. Okay, so out of all this, oops. I apologize again. I seem to have lost my cursor. So again, this is kind of reiterating what I was saying before. But the opportunity that we're really, my partner and I, we were commiserating about these issues. My partner is a product line manager, was a product line manager at a semiconductor company, and he had pretty much the same problem. He had all this data sitting in data warehouses and so forth, but anytime he wanted to have build some, test an idea, test a hypothesis, it was impossible given all the tooling and the manpower in the middle. So there was no direct access to any of it. There was no way for him to directly drive what he wanted to do. So that became one core tenet for us. Self-service. Enable every one of those groups that I was talking about in the previous slide to be able to do their job and to be able to leverage what the other teams are doing. So that's an important goal. Abstraction. Abstraction is important because each of these groups have their own terminology, their own vernacular that they use. And it's important. I mean, Rich Hickey famously has demonstrated the need for using words correctly in the right context. Abstraction is important because each of those teams, to be productive and to be effective, they need to see the process through their mental model. So abstraction. Collaboration. Each of these functional groups, functional teams, needs to be able to contribute just as much as they consume and as effectively as they consume. So it can't be data science produces something and business analyst uses it and there's no backward propagation of information or insight. So that needs to change. Yikes. Okay, so before I go further, I want to clarify one thing. So the title of this talk is Clojure for Business Teams. I want to emphasize what it is and what it isn't. It is not substituting Clojure for R or Python. I don't think that's the right way to go. It is not another Clojure IDE, at least not IDE in the conventional sense. It's not a DSL. It is about rethinking data tooling, but applying all of the learnings we've taken from Clojure and its ecosystem. And these are functional abstractions, composition, interactively building and testing, immutable data. These are the concepts that we need to figure, that we've figured need to be presented to business users, non-technical, non-Clojure developers. So, without further ado, this is what Juxt.io is. It is it uses a visual schematic metaphor, a drag and drop canvas onto which functional blocks are placed and they're wired together to match whatever appropriate data flow is required. It's kind of like Lego for data, but it's got Clojure underneath, so it's actually Lego for data with Clojure, which is like, I mean, how cool is that? Okay, so I've talked a lot. Let me show you some stuff, and then we can. So Juxt.io is a fairly nascent project. The UX and the UI is constantly being changed, but this is roughly how we organize things, and there's actually a certain parallel to how Clojure organizes namespaces and functions. So we have projects. Projects are kind of a group of, almost like projects are a jar boundary. So you can have a bunch of modules. Each of those modules are themselves namespaces. So let me open one of these. Appropriately named Clojure conj demo. This is just a very simple flow. All it's doing is it's generating an inclusive range, which is really just a range, but with the upper end included, the top end included, and pushing it through a collect, which is really just a map, and printing it out on the console. I'm going to run this, and then I'll get back to explaining what's actually going on. Okay, so it prints out a bunch of numbers. So each of these blocks has a certain set of properties, and those properties can be defined via literal values or as signals coming in from an upstream block. Each of those blocks has a value out which can be taken out to the next stage. Collect, which I mentioned, is a kind of a quick word on terminology. So we kind of A/B tested different terms with business users, and for whatever reason, map filter reduced didn't pass. We ended up with the small talky sounding collect, select, and reject, and so forth, and roll up. Anyway, so collect is essentially is a map, and it takes a collector, which is in fact another module in and of itself. And in this case, I'm using a square.clj, which is, I'm going to metadot into this. And that's really just this is an abstract component. This is an abstract graph where it has a unbound input, which it expects the caller or the user to supply, which goes into, in this case, a literal Clojure code block. And this is where you can more or less, it's an escape valve for going straight through raw Clojure. And the output goes as an output binding. And that's really it. What it's doing is exactly what map does. It takes the list of numbers, the sequence of numbers, it collects over them, generates a new collection, which gets printed out using a console print. Okay, so let's look at what's behind this a little bit. Okay, so the anatomy of this graph is really, like I was saying, each one of those blocks is backed by a function. Inclusive range has those arguments, collect has those arguments, console print, and the graph itself is represented by a structure very similar to what's in the code fragment at the bottom. So you could almost see the threading arrow going from port to port there, right? Okay, and the square abstract module is literally that. So I apologize. The example that I showed was using a Clojure code block, but there is an implementation which uses this expression block, which is an infix, mini infix language that business users like. And that's actually thanks to Mark's amazing Instaparse library. So again, one quick point. Expression actually takes what's called a variadic parameter. So it's one of these parameters where as you keep adding new signals to it, it will allow for more signals to be added. So it's essentially like a var args in a visual way. Okay, so that's a fairly straightforward graph. What happens when things get a little bit more complicated? So this is a reasonably typical data science task where we load some kind of data set, split it into a training and test set, apply some kind of ML algorithm to it. In this case, it's training a linear regression predictor, and then we want to test the effectiveness of the predictor using the test set. So the graph more or less describes what's happening there, and the code down at the bottom is trying to, it does pretty much the same thing. But you can start to see the moment we look at the code, this requires someone with Clojure understanding. You need to know what the lead binding is doing, who's referencing the lead binding, and so forth. Whereas the visual flow is something that a non-developer can look at and pretty quickly understand what's going on. They may not necessarily understand how linear regression is implemented or performing, but they can more or less follow the logic and click through and look at the states. And this is something that we've had a chance to observe with user groups, where we've had completely novice product managers and product line people sit with this environment and start to, after a little bit of training, start to build fairly interesting graphs. In fact, this flow and another flow that I'll show later was actually built by someone who has no development experience. But this is clearly a well thought out functional flow. Okay, so one clarification. This is not to say code sucks or something. Obviously not. It's code is always going to be more succinct. It is going to be in terms of flexibility. There's always going to be more ways of working with the code than there is in this in the visual form. But the visual form lends itself to easier understanding and knowledge transfer, discoverability. These are properties that come almost for free with the visual flow paradigm. Okay, actually, let me switch back to the demo. I want to show a couple of other examples. I don't know, I'm doing a time. Okay, so these flows that I talked about are still fairly low level. They're probably things that a developer or a data scientist would build. So let's talk about something that a product line manager typically uses. Okay. So this is one of the other flows that I was talking about, which someone who's a non-Clojure developer built. Let me run this and then come back and talk about it. Okay. I preloaded a lot of the data, so it just runs better. Anyway, so this is a very typical sales dashboard that shows things like how are certain products doing in, say, different market segments. Who are my top 10 customers? What mean lifetime revenue am I seeing from them? How's my product, one of my primary market segments performing at a secondary market level, or maybe something across geographical regions and so forth. So it's fairly straightforward, something that probably gets built a million times in different business units. And this is more or less how it gets built in Juxt. There is some import process. Presumably it's an ETL process that's running in batch, or even it could be integrated right here in line. The values coming out of that are being pushed into a block called portfolio summary. Now here's the abstraction at work. Portfolio summary is something a product line manager understands. If you had a palette of these blocks on the site, there are in fact a palette of blocks on the sites which I've neglected to mention. If you had a palette of these blocks, a portfolio summary makes sense to a product line guy. He would pull that in and expect that when he pushes his data into it, he gets some kind of graph that looks like the chart we looked at earlier. The top 10 customers is another block. Segment stats is another block. Segment stats has some, presents its abstraction for, and expects to be sent what segments the report should be presenting and so forth. And the results of these blocks is being merged back into an HTML page and rendered to a link. And there's also an AWS method in this which sends out an email. So presumably every time this dashboard gets updated, you'd want to be notified about it. Again, each one of these blocks does one very specific thing. You put them together, you start to see more interesting patterns come about. Okay, so the last demo example that I have is actually a fairly full-fledged data science use case, which hopefully illustrates this point that once you have this visual abstraction, then there's really nothing you can't put into one of these blocks. It could be something as complex as random forest, or something as straightforward as sending an email, or doing a map. So here's an example, slightly more involved. What it's doing is it's loading the same data set, training a linear regression predictor and a random forest predictor, and just generating a comparison of how they do against the original values. So let's go ahead and run that. Okay, I'm not sure this is all that interesting to look at, but basically gives you an idea of how each of those predictors performed. There's some interesting things going on here in terms of translating low-level Clojure primitives into, or built-ins into the right abstraction for the data scientist's point of view. And also in terms of introspection and debuggability, there is we've got some interesting stuff going on here where you can, once you've run this, you can go introspect values. And this is showing you results from the last evaluation. We're also working on features to do partial evaluation. So the ability to save the state of a part of this graph and invoke the rest of it so that you can sort of prime your test environment and iterate through many test cases quickly. Okay. Okay, so I want to switch gears a little bit and talk a little bit about what's under the hood. So as I said, everything, all of these blocks, these graphs, they are just functions. They're just Clojure functions. This is a helper Macrodef module, which essentially ensures that everything that is required to turn a function into a block has been provided. ID is a GUID in this case. It could be anything actually, but as long the key idea here is that the name of the component, the name of the module, is not a unique identifier. It can change. It can be different, and it shouldn't affect uses of it across the system. The other piece here that's interesting is the inputs, the properties or signal ports are really just it's a declarative definition of what each input is, what kind of schema it takes, and what the output type is. Unfortunately, the example that I picked, and I realize it's too late, isn't rich enough. But that schema definition can get fairly specific. It can be quite tuned. And the body of the module is really just the Clojure function. So no magic really. Okay, and sort of the orchestration of all of this is we split it into a design workbench piece and a deployment piece. The design workbench is the interactive piece, or the front end where all the wiring happens, the drag and drop canvas, the inspector, the debugger, all of that is the design piece. When you hit run, that evaluation is actually happening in the deployment piece, where we have a source-to-source transformation of that graph into Clojure code, and that Clojure code then goes through Clojure core compiler. So again, no magic. It's just data being transformed. Yeah, I got Lean in there, so we actually also have Pomegranate and Vinyasa, which was a great little library for reloading things in place, so you don't have to fire up and fire down Java instances, JVM instances. The product of the transpiler can be compiled into an Uber jar and deployed completely independent of this. So, one use case really is where we have a hosted design environment, and all of the deployment happens in a private cloud somewhere. So the stack is, again, I hate to admit it's not anything fascinating. We've got ClojureScript, Ohm, and Figwheel to handle all the front end stuff. The design services is all, it's almost motherhood and apple pie libraries at this point. And a big thanks to all of the amazing developers who put out these meticulously crafted libraries. So, really. Okay. So none of this is, dramatically, new, original. Visual environments and data flow for analytics have been around forever. There's some great examples: Yahoo Pipes, Apple Quartz Composer, Scratch, numerous other ones that I'm sure I'm missing. It's a proven approach. But what's interesting now is combining that approach with Clojure and its ecosystem, I think, introduces, it could be a seriously game-changing effect. We could see some new things happening that, a new class of developers who aren't necessarily Clojure developers or coming to Clojure via other means. So anyway, that's my pipe dream. Okay, what's next? As I said, we're a fairly young project. We just got a working alpha release out. We've been working with a few customers in pharma, IoT, and semiconductors. Part of the reason is actually this Conj talk is the first that we're coming out and socializing the ideas behind Juxt. Part of the reason for that is we really believe the end application of Juxt has to be driven by a non-Clojure community, and so we've been focusing on that. But now it's to the point where we think the ideas have been vetted, and it's time to get my people, my brethren, to involved, and seriously, we're at this point keen to see what challenges you may yourself be facing, applications that you think something like Juxt could be interestingly applied. I just want to quickly thank a few people, especially Lynn and Alex, and all the other folks at ClojureConj for inviting me. I'm super excited to be here. I mean, I'm really going to start enjoying the conference after this is done. But again, I wish you all a great conference. Any questions, I'd be happy to get into. Yeah?
Now that you're starting to release this for a while, what lessons are you learning? What are you being taught by so far?
The primary, certainly from the technology stack point of view, we didn't have any major surprises. I mean, we learned a few things along the way. For example, the first incarnation of Juxt was very monolithic. It had everything, the designer, the compiler, everything was in one piece, and that was limited. Another lesson we learned was the way those modules and those libraries get imported, we needed to rethink that. And we've re-architected in a way such that it is very easy to take any open source library, whether it's, I mean, for example, I didn't go through that library list in great detail, but we pulled in things like Weka, CLJML, Incantor, Amazonica, just great libraries. But we got it to the point where we were able to bring these libraries in with minimal effort. Like literally, I mean, especially the well-designed ones, there's virtually no effort. You're just sticking a wrapper around it. There are some libraries where they're more imperative, and therefore there's that aspect of it. These aren't Clojure libraries; these are Java libraries. So there's that part of figuring out what that abstraction needs to be, and that's a constant process. We're constantly learning how to build the right abstraction for the right user. So I don't know if that helps. Yeah.
I have two questions.
Sure.
First, does Juxt handle the extraction of the data and putting it into where it's ultimately viewed? And the second is, I know that Java interop is sort of a huge thing in the Clojure community. You were just saying that adding other libraries to Juxt is very, very easy. Is that also
true for Java? Great question. So the first part, yes. The short answer is yes. We do handle. You can pretty much anything that you think of that you could you would say I can use Juxt for doing. I mean, I could use Clojure for doing this. You could probably think of Juxt as being equally applicable. So if it's data transforms, by the way, that's not a plug to say use Juxt instead of Clojure at all. It just means that a non-Clojure developer might be able to do some of those things. I mean, I'm sort of ranting a little here, but can you imagine the number of times you get pinged as a developer to do things that you wish people could do themselves? And what do we end up doing? We end up building custom user interfaces for those things. We come up with, I got to build this importer or that thing. Instead, if we could just say, hey, here's a few blocks. Here are a few blocks, and this is how it roughly works. Go to town with it. So that's one part of it. And your second question about absolutely, Java interop is great, but that is exactly the place where the abstraction problem exists. Turning those imperative, design, approaches into a functional data flow ready path sometimes poses challenges. The Clojure libraries are a breeze. I mean, literally, you could add a meta map to a Clojure function, which is what def module does anyway, and you'd be done. So it's the impedance mismatch between the imperative and the data flow where time gets spent. Yes?
The previous implementations of applications like this, like Yahoo Pipes, where they failed, where does this provide
Where does that bridge that gap in terms of making the solution one that will go further than where Yahoo Pipes may have failed?
That's a great question, actually. I don't know if everybody got that, but basically, why is this different, or how is this better, right? Other than having Clojure, how is this better than the approach, say, Yahoo Pipes took and so forth? So, now Yahoo Pipes was a very purpose-oriented platform. They didn't try to be very general purpose about it. It was about processing RSS feeds and general web web formats and so forth, mashups, if I'm not mistaken. And I don't think Yahoo Pipes necessarily gave you a very good extension capability. It wasn't something where you could easily extend it with your own primitives in some way, or add on a, import your jar and say, this is what I want done. Actually, a few things that I did not get into, and I apologize because there's a lot of stuff and I had to make some priority calls on what I actually presented here. So to directly answer your question, it's hard for me to talk about a specific set of things that differentiate this, but I'll just list them and maybe we can draw some conclusions from that. One is Clojure in the Java ecosystem, right? Clojure in the larger Java ecosystem, which means you have a much larger set of things that can be plugged in. Not all of them can be plugged in with the same ease of use, but they can all be plugged in. The second aspect is because we had the benefit of hindsight, we started with this idea that the design and the deployment are distinctly separate concerns. So there is really no, there's nothing that ties us from, say, having all of this Clojure front-end capability Java ecosystem, but rendering something that's completely different. Because we're doing data transforms. We could just as easily, assuming all of the appropriate infrastructure were in place, we could just as easily generate, say, C. In fact, there is an IoT application where we've been tossing this idea around, where a graph gets compiled to C, and that C piece would be compiled into an embedded environment. So again, the aha here really is a synthesis of different ideas, no one of which is unique or significant in and of itself. But I think the ability to put it all together and make it work end to end, maybe. Does that work?
It's still that bridging the technical side to the people who traditionally today are Excel users, which is the business side.
Yeah.
And it's still finding that gap, and there's still difficulty in the space trying to
Yes.
bridge the learning gap.
Yes, there is. I mean, I will not deny that. I mean, there is still a learning curve associated with even something like Juxt, but maybe abstraction can help with that. If we turn blocks and if we turn processes into not just terminology, but flow-wise as well, separation-wise as well, into things that are identifiable in specific business domains, then maybe there's hope. At least we got to try. Yes.
So you heard Excel mentioned a lot.
Yeah.
One of the best qualities of Excel, which is also one of the worst qualities, is that it's just one giant computable grid.
Yeah.
Basically a state.
Yeah.
So if you see something, you can use it. Have you what are your thoughts on using intermediate results or turning a result, a function, into an intermediate result that can then be passed around?
Great. Almost like a continuation kind of thing. So you wrap up part of. It's an idea that's actually been bandied about. So part of the partial eval feature that I was talking about earlier, I wish I had that ready to demo to you guys, but it's not. Part of that is the ability. It gives us a couple of different things. One is the ability to iterate without having to rerun large parts of the graph. The second is resilience. If this node, imagine a distributed cluster in which the computation has taken place, the node dies, we have the ability to resume that node because the data could be replicated. The key aha again is that's data. We can take that and push it into another node, or simultaneously populate two nodes. You can be running without skipping a beat. You could switch. To your earlier point about Excel is great. There's even some very cool stuff that I've seen about putting Clojure in an Excel cell and a Clojure script in an Excel cell, which is great. But fundamentally, Excel, fails for the other reason that you mentioned, which is it is all one place, and the only way for me to collaborate with someone else is to hand that entire thing over, and then when they make a change, for them to hand it back to me, or I guess maybe build a Visual Basic macros or something. As a metaphor, as a UX metaphor, grids are great. In fact, we've even considered doing that for parts of this. But I still believe that the data flow is clearer. I mean, after some threshold, after some point, a complex Excel spreadsheet is gobbledygook. I mean, you just lose track of where things are happening. And I've actually seen a debugger for Excel macros, which decompiles it back into a data flow. Makes it much easier to look at, much easier to reason about. So, not discounting Excel, I'm just saying that maybe the two can coexist. Be a nice, happy family. Okay. Oh, yeah, sorry.
Before you showed an example of when you're working in the design view, after you ran it, you're able to go back to the value
Yes.
of
Yeah.
that spot.
Yeah.
Are you able to see a full data set in between the changes at that point?
Yeah, that's a great question as well. So I kind of cheated there. So right now, the way this feature works, so we're actually collecting all of the intermediate state. So yes, to answer your question, we can. We don't have the UI for it. Because this is the challenge. The moment because this is hierarchical, it's compositional, right? You have abstract modules beneath. Modules are being composed together hierarchically. If a failure happens, let's say 3 levels deep, and you catch it, how do you communicate this to a non-technical user that there's a stack involved and you need to navigate down to the, so we're kind of sidestepping that a little bit. We're basically saying an error happened at this top level module. And by the way, the state that's involved with it is this. It may not be adequate for you to debug it, but it's the best UI we could come up with so far. But those are the kinds of challenges we want to be addressing. How do we turn this UX into how do we improve the UX to where a non-Clojure developer or non-technical user can think about these things in terms of, oh, I have these different levels of abstraction. When I look at it through this lens, it's this information. When I move this lens, I'm seeing this next level and so forth. So these are some interesting, at least they're more interesting than just writing reports, SQL reports. Anyway. Yeah? Okay, thank you so much.